Answer. We shall start.
Welcome to today's mob.
Oh,
Kevin,
Welcome to today's mob.
please stop correcting me every time.
We might have technical errors. Kumbuka, this is a live event. We might have technical errors.
Yeah, I was muted. I don't know. I think it's yeah. So today we'll be doing this kata. I was okay. I was unmuted and not from the beginning. Okay. Okay. I will start again. Welcome for today's mob. We will. We have Crafty and Kevin and me, Lucy, and we will be doing this kata here. This one. Sum of two integers, and it's a 6Q kata. So enjoy. So the available languages are C, C++, Java, JavaScript, and NMS. I don't know what that is. Yeah, but here, I think everyone here is conversant with JavaScript. So that is what we will use. Yeah, so who will read for us the instructions? Crafty?
Okay. So, given two integers, A, B, find the sum of them, but you're not allowed to use the operator addition and subtraction. So the notes are the numbers A, B may be positive, negative values, or 0. Returning value will be integer. And JavaScript, the array reduce methods are disabled along with the val, require, and module. Java, the following methods are prohibited: add, extra, average, collect, decrement, increment, next after, next down, next up, reduce, subtract, sum, summing. And for Nazm, the following instructions are prohibited: add, hey, what are these? Adduc, addix, addox, dec, inc, sub, and sub. Yeah. And we have input output examples. If you may scroll, please. Yeah, so when you add, you get the result. So that's it. 5 by 19, you get 24. That, you get that. 14, 16, you get 30. Yeah, that's it. So let's challenge ourselves.
Yeah. So if it was Python, we have some method. Yeah, we could have converted the numbers to arrays to a list, and then we could have used some method. But in JavaScript, I don't think we have such a method, so we'll find our way around it. So I can see controller is trying to do something. Have you found anything? Yes? No, I can't
I
hear.
have an idea.
Yeah, now I can hear.
So we have the first value
Yeah.
is A and the second one is B.
Yeah.
We are not supposed to use eval,
Yeah.
and we're not supposed to use we're not supposed to require modules, right?
Yeah.
So what if we use a for loop
Yeah.
through and increment 1 each and every time until maybe if it's 5 and 19, we increment 19 times to 5. 5 plus 1 plus 1 plus 1 plus
But
1
we'll be using class.
plus.
Yeah, we will be using class. We're not supposed to use class or minus. The addition or subtraction operator, you're not supposed to use it, and you're not supposed to use reduce methods along with eval, require, and module. So no, I feel like this is a programming logic problem. Like, I think it's just a trick. Like, for example, if you're supposed to multiply numbers, you can add them, right? So, like, I feel like this problem, this kata, we're just supposed to find a way or a method to do it in such a way that you're not really using the sum operators, but you are adding it. I don't know. Um, like somebody say something. Let me Google. Adding to
Are we supposed to use the asterisk multiplication?
yes,
Yeah, we can
you
use
can
that.
use other operators, but
So
yeah,
I have an idea.
yes,
What we will do this,
yeah,
we put a string,
yes,
a one character string,
yeah.
even if
That is X.
X
Yeah,
or a star or a hash,
yeah.
just a string,
Yes.
and then we multiply it.
A string. Yes.
Then we multiply it the number of y times
No, that is like
and concatenate
yes.
with the number of x times, and we find the length.
What? We?
Yeah.
We get the length. We do those length.
Can you just like say it again from start?
See what you've done.
Yes.
String x
Yes.
multiplied by times,
Yeah.
of which it won't be possible in JavaScript.
Yeah.
But this is the concept.
Yeah.
And then we do y, the string x again, another string x times.
Okay.
So maybe
This
in our
means-
example, our string x multiplied 5 times and multiplied 19 times. Then we concatenate the two. We concat the two and get the length. Oh yeah.
Okay, like
So
x multiply x time. I'm not getting.
The first string and not x and y. So that's just a random.
Yeah, but I'm not getting you what you're saying. Yes. It's not different, but okay. Yeah. It's- I'm not getting.
Hey, oh, can you guys hear me?
Yes.
Okay, so whenever we have the function, when we call the function add, we pass it a number. Yeah? The number is x and y. So Rafty was trying to say that assume now we have a string, a one character string A. If we multiply it x number of times, which in this case x according to the test, the first round is 1,
Yeah.
the second round is 5,
Yeah.
the second one is 23. Yeah, let me just use for example the second one. If we multiply it 5 times, we'll have a 5 times. Yeah. In that case, if you take the length at that point, it will be 5.
So
So assuming
this is
you
what you're
took
saying.
a, you multiply it by, we multiply it by, if you put a like this, it means a is a variable. But the value you are using is x on the add function. Yeah. Then another one, then we multiply by y. But will this be applicable for negative numbers?
So
I
we
think we could use that.
no, we won't use an if. Let's just
Can we just try like a times negative,
yeah,
like
yeah. Please.
like
Because
like?
No, you can't do that in JS. It will give you an A. And can you please try? String A times 5. None, not a number. Times. What is n?
what is n?
N, not a number. So in JavaScript, you can do so.
Okay.
The concept when you want to increment a string is to use a while loop and such.
But we could. Let me just write this. Let me just complete this first. Yeah. And then we can do the length. Like this is what you're trying to do.
Yeah.
We're trying to find the length of this and this. Okay. That is a valid one. So let's try implementing in JavaScript now.
Can you please put the you put the curly braces at the end of y? It looks funny there.
But it was like that. Yeah.
Thank you so much, Lucy.
Perfectionist. I so what if
Should we try
I
it
can
out?
hear you?
Should we try that out? So
Yeah.
let's.
Yeah.
How can I write on the board?
You can't write on the board. Write on your terminal and then you share your screen. Yeah, so I will. Can I? I'm already on your screen. Yeah, we can see your. Okay. Yes. Can you maximize your terminal? Okay. Yes. I can't hear you though. I can't hear you.
So,
Nimesongewa kiti.
so
So,
can you hear me?
yes.
Yeah. So I was saying this. We have to print. We have a function
Yes.
that takes in A and B,
Yes.
right? And in this function, this will be a net. Yeah, function that takes A and B, and we're supposed to add the two.
Yes.
Yeah. So in real sense, we would have done just A and
A
B.
and B. Yeah.
But what we want to do is to create a string
Yes.
like that,
What's that? Yeah.
and multiply it A times,
Yeah.
and the same string on another string multiplied B times.
Yeah.
We concatenate and find.
Find the length. Yeah.
Since we can't actually multiply a string a number of times
Yeah.
and get the value,
Yeah.
we will use a while.
Yes.
Yeah. So we have a function loop
Yes.
that takes in.
A.
Uh, no, let's just have it that way. We have a function loop.
Yes.
Okay. And in this function loop, we have while. No, let's not do that. Let's have A equals to an empty string. So we have an empty string, and then we want to say while x.
Yeah. You could say while x
Is greater than 0.
is greater than 0. No. While x is less than the real value of x. Sorry. Like,
It will terminate immediately after the first increment will be finished.
I'm trying to think. For example, if x is 5, so while I think we have to have many variables.
We have to have two arguments.
Arguments,
Yeah,
yes.
that's why I have just realized. So
While, okay.
Function loop that takes in two arguments, right? Yeah. So we have y as our empty string. We all know that we can concatenate, we can concat a string with a string.
Yeah. Yeah.
Yeah.
So does that mean if you say a dot concat a, the strings, you'll get a.
Yeah.
Okay.
Yeah, A the string, not the variable, A the string.
Yeah.
Okay.
And if you find the length, you'll get 2, not 1, because it's the same string. You'll get 1.
Yeah, I'll guess. Yeah.
Okay.
So
Can you just try or no?
let us continue then.
Okay.
Yeah. So while the A
Yes.
is greater than 0,
In your craft.
while A is greater than 0,
Yes.
what we do is we take Y.
Okay. Let me just ask a question. A and B are the numbers that you're supposed to add.
Yeah.
Y is our string.
Yeah.
Okay.
So Y plus equals
Yeah. But you're using the plus operator there. You're not supposed to use it anywhere.
No, it's okay. What we should not do is use A plus B.
But
But you can use it.
No, she's right.
you're not supposed
I
to
think
use
she's
the plus operator.
We have
Okay.
concat as a string method.
Yeah.
So why don't
Dot concat. Yeah.
concat? Help me here because nimeanza kupoteza akili.
Yeah.
Why dot concat? Hash.
This one. Yeah, why are we concatenating y?
Hash is no, y is our empty string.
Yeah, why are we concatenating the hash?
That's just a random string. As we said, you can use A, B, or star.
Okay. Okay.
So we concat the hash
Mm.
to y. So for now, we have our y length as one.
Yeah.
So what we do is
Increment. But you're using the subtraction,
subtraction again.
operator. You're not supposed to use them. Yeah.
What is this guy?
Oh.
But you know, we would have solved this thing.
Because
Yeah.
okay, can you do the explain?
I can't hear you.
Can't hear you.
I was putting it, but I can hear myself.
Yeah,
But we can't hear you.
I'm listening. I'm listening. Okay. I was listening. So, hey, will I have to share my screen too? Okay. So,
Oh, I'm supposed to be on your screen. Yes, Kevin.
yeah, my screen. So there is I was googling when there was wait, did I close it? Oh, this one here. Without using.
Yeah.
There's this bit here where they're using bitwise operators and using recursion.
Yes.
So I was trying out something here. If you have, let me, does it really work directly like, yeah, something like that? Huh?
Yeah. Yeah. Yes. Then can you zoom?
Huh?
Zoom.
Oh.
Yeah. That's okay.
Okay, but I was not really understanding the logic here.
So this one, this sign here. Can you see my? Okay. I'm pointing at that one
Yeah,
and the and
yeah.
and the less than. Those are the bitways operator. What are bitways operators?
So if you come to, let me just open this.
Hide. Hide.
Oh, so these are the bitwise operators. We have and
This one.
oh,
It's me. I think it's me. Stop. No. Don't stop.
Why are you sharing the screen? It's sharing. You should lock the screen.
Yeah, that is what I'm doing. I'm on his screen right now. Yeah.
I'm sharing the screen. You sharing the screen.
oh, you should stop sharing it. Yeah. Okay, so here are the bitwise operators. Here, the and that you're saying, this is the shift. This is the bitwise X. So returns are 1 in each bit position for which the corresponding bits of either but not both operands are 1. So
I don't know.
I can
Can you just go back? You don't go up.
back to back.
Like the introduction. No.
Oh,
The introduction of bitwise operators.
okay. So I think you can use this example to see what's really happening. For example, if you have 5 and 3, the 5 is
It's written in binary
in a
form.
binary, yeah?
And the 13
Same to
also.
13.
And then they are added.
If you now take and what does now and returns a 1 in each bit position for which the corresponding bits of both operands are 1. So
Oh, I see.
in this case, if you have we have a 1 and a 1, yeah,
Yeah, so you get 1.
you'll get a 1.
You have a
The
0
one is 0 and a 0.
and a 0. So you
So you
get
get a 0.
Yeah.
The following is a 1,
1 and a 1.
1 and a 1.
So you get 1.
So you get 1. Then
Then
a 0 and a 1,
1,
you get 0.
0,
So the resulting value of doing that is this. Yeah?
which is 5.
Yeah.
Yeah. So let's try
So
with
I
what we are
think now
getting.
with this, I think with this explanation, we can see, we can now, okay, now, for example, now, if you use now,
Or
so it returns a 1 in which, oh,
each.
it returns a 1 in each bit position for which the corresponding bits of either, but not both operands are
Are 1.
ones. So, in this case, if you were to do, is it editable? If this was like that, yeah.
Yeah. Run. See,
In this case,
you'll get.
if we have, for example, now we have a 1 and a 1, so that will be 1. The moment you have 1 in either, it returns 1.
No, it
Okay,
returns 0.
let me go back. Returns a 1 in each bit
Bit.
position for which the corresponding bits
Yeah.
of either,
But not both.
but not both.
Yes.
Oh, so
Other
if
ones.
it's, oh,
So if it's
then
1 and 1.
so 1 and 1 here it should be, in this
0.
case it will be a 0.
Yeah.
The next one is 0 and 0 will
So
remain 0.
1.
No, it only returns 1 if either is a 1.
No.
If either is a 1.
No.
Okay, let me go back.
It,
Returns 1 in each bit position for which the corresponding bits of either,
yeah. But. Yeah.
but not both,
Both.
are 1. So it returns 1 if either is a 1. So if this is 1 and this is 0, it will return 1. If the other one is 1 and this one is 0, it will return 1.
But we have not been
If you have a
told.
1 and a 1, that's a 0.
But we've not been told about when it's both 0 and 0.
So this is like 0 and 0, that is like
A 0 or a 1.
okay, according to this statement. Crafty, how
Returns
did you
1
get it?
in each bit for which the corresponding bits of either, but not both, operands are negative, are 1 of either.
So, because, okay.
Okay, 0, 0.
Like this, it was a 1, 1, so it was 0, then 0,
So-
0 is a 0. The
And
next one is a 1, 1.
1, so it's a 0.
It's a 0. Then a
1 and 0.
which is a 1.
1. If we convert this
Uh-huh.
to just run, we see if we are correct first.
So it should be, yeah, it's 8. This is a 8.
Yeah, and this is,
Which one?
as in, I'm trying to convert it back to decimal.
Yes, it's 8. This one.
Oh, it's 8. So,
See,
okay.
10 is usually 10, 10.
Yeah,
9 is, you add 1 here. That's a 9.
yeah.
Then, yeah, and this is 8.
Yeah.
So, okay, using that, I think now from this logic, we can see.
Exactly.
Hmm?
Yeah. So you may minus. That, yeah, you get 8.
But it depends. You know, It is not that it has really minus, but it depends with what you're passing. So we can
Can you just
change.
go back? Yeah,
Let
there.
me change it to even 1. If you're saying it's minusing, then you're expecting 4.
A 4. Yeah.
But we know that 1 is, okay, let me just write it here. 1 is
0.
1, 2,
Yeah, like that.
1.
Yeah.
So in this case, according to our understanding, if you have a 1, 1, that's 0.
Yeah.
If you have a 0, 0, that's 0.
Yeah.
You now have a 0, 1, that will be 1.
Mm.
Then you have a 0, 0, oh, that is definitely a 4.
Yeah. So I think we were not right
We
on
were
the
not
one,
right.
on the other one. The first one, the one we got 8.
We were wrong.
Yeah.
We were wrong
Because
in more than, okay,
can we
continue.
just go back? Like, you see, we've said that one and we've gotten a 4. Maybe we could prove with another one and then we can go back. As in, we've said 5 bitwise or, I think.
Yeah.
No, bitwise?
It's a bitwise XOR.
XOR. Yeah, bitwise XOR. And we've gotten a 4. So I'm saying,
Oh,
can we
use another
try?
example.
Yeah, can we try with another one? And then
Okay, let me use 4.
4. Yeah, I'm expecting to get 1.
4 is usually
100.
100, so it's 0.
And then 0, 0. Yeah,
And
0.
0.
So I'm
So this
expecting
is a 1.
1 and then 0, 0, 0.
The rest are
0
yeah,
and 0.
the rest are 0.
You get 0. Yeah.
So
So you
the
see
rest
that
are
is 1.
0. Yeah, this is 1.
Yeah, that is why I'm saying the first one we are not right.
So what happens if we have a 7? No.
The first one we were not right.
What about if I have a 5? 5 is a 1. 5 is a 1. Oh, if we do a 4,
Like, yeah.
it's correct.
Yeah. So I'm saying the first value we had, it was 5 and 13. We didn't do it correctly because we were getting 8 instead of 18.
We're supposed to get
18, exactly. But we got
No, what is 13 minus 5?
13
What
minus
is 13 minus 5, Miss? Is it 18?
No. We are minusing.
You said you were
But-
minus,
Um.
which is at 8.
So it doesn't matter the position because it was 5.
Okay, we can test another one. Let's put this
12.
at 10.
10.
If
So,
this is a 10,
okay.
so this is a 10, 10, 10, 10. So in this case, this will be a 1, 1. Because it's a 0 and a 1, that's 1, yeah? A 0 and a 1, that's 1. A 0 and a 1, that's 1. Oh boy. Then a 0.
No,
Hey,
no. It's 0 and 0. 1 and
It's
0.
like
No,
this.
it's 1 and 1. See,
No.
0 and 1 is 0. Sorry, it's 1. 1 and 0 is 1 again.
Yes.
Okay.
0 and 1 is
1.
So this is which number?
This is 7,
Oh,
15. 15. Yeah.
this is 15.
Because 111, 111 is 7.
And you are
And
saying
then-
it's minusing, so it's not minusing actually.
It's adding.
You concluded that this is minusing.
Yeah,
So it's
because
not minusing.
we feel. Yeah.
No, it is doing what it. We are just concluding. But that's not.
But, listen,
Uh-huh.
this is a bigger number than you've seen. We are getting different numbers when we have a smaller and a bigger number. And then we have small and big.
Okay, I don't think the order doesn't matter because it just checks what you are doing the bitwise XOR. So the order will still be the same. Even
I don't
if you
think
start with the 10 first and 5, it will just check the first character here and the first character, the second character here and the second here. the third here and the third here. So the other doesn't really matter.
So the conclusion is
So there's no conclusion here whether this adds or minuses. It just
it
shifts.
is random.
No, it is not random. It just does this, like we have.
Yeah, but
Yeah.
when you're using it,
Yeah.
but when you, yeah,
Yeah, this is what it does.
yeah, but when you're using it, does it mean that you don't know what you'll get?
When
Because
you're
it's
using
random.
it, it's not random.
Okay,
It does this.
zero.
Yes, yes, that's it. So that's not random. Yeah.
Because if you're saying it's random, 5 because X on 1, it will give a different value. Now,
Yeah, that is my point.
No, it's not like
but it's
that.
not like that.
The value of 1,
plus 0 will always
yeah, its binary value will always remain the same.
But my point is the fact that we don't have a conclusion if it's adding or subtracting.
Means it's random.
No, it's not random per se. It's just it's almost like you don't know what to expect.
No, we know what to expect because what this does is checks for either of the bits, and if either of the bits has a 1, then our result is 1. Yeah. If both is 1, so that's a 0.
Kevin, I'm not disagreeing with you. I'm saying it's not like when we say 2 plus 4, it will always be 6.
Okay, 2 plus 4. Okay, let me answer, Mister. 2 plus 4. Oh, how is 2 plus 4? Okay, when you were growing up, probably you take 2 things this side,
Yeah, and
4
4
things this
this
side,
side, and then
put
you
them
add.
together, you come up with a 6. Yeah.
Yeah.
But in this case, the way now the bitwise order will be they will be handling the bitwise. If now in this case you're checking the bits. You're checking the bits. If this is a 1 and this is a 0, your result should be a 1.
So
That's the what? How is it called?
5 10 is always.
Yeah, the way 2 plus 4 is always. It's not, yeah. Okay. Yeah.
You give contradiction answers. Subtracting and adding.
Like my point is this: if you give me 10 plus 14, you'll get 24, right? If yes, if you say, if you give me now 10 plus 13, I know what to do. I know I will do, or rather, I know what I'm.
Okay. Actually, you know you'll do what? Actually. Just from there, if you have 10 and 13, you know you'll do what?
I will add 10 and 13.
So you'll
I'll
add.
get
So in fact, you'll be adding. You will not add. If you have 10 and 13, you will not add 3. You will not add 3 and 1. How do you know that you should be adding 0 and 3?
because that is how it is done.
Yes. Thank you. Thank you.
I want you to
So,
say something.
yes.
I'm not disagreeing with you.
Yes, you don't say that.
But you're
I'm-
confusing yourself by saying
You don't know what to
expect. She is saying that we always expect a higher number than a lower number. So it's an prediction. That's what
Yes.
but that's it.
Okay, let's continue. We will stay here.
Okay, so I think at least now I've understood this part. The next part was
And
this.
between
Yeah,
and.
yeah. The next part is this.
Can we go back to
So
see?
if we see now, if we understand now how that, which is, initially it was, okay, let's see, and what the, so what the bitwise AND does is returns a 1 in each bit position for which corresponding bits of both operands are 1s.
Yeah.
So if we have an, okay, let me use which one? This one here. Let me use, remove this. So return 1 where we have both 1s in, okay, let me go back. It's like this is just like a normal truth value for the and.
Yeah, like logical and.
Yeah.
It works the same as logical and.
It's only one if both. Yeah. 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 So in this case, like
So
5 and 13.
remove the answer first so that it doesn't confuse us.
Okay.
Yeah.
So like
So
5
1
and
and 1.
13. The first one is 0 and 1, which is 0. 1 and
1,
1 and
1, 1. 0 and 1, 0 and 0.
is 0.
And then 1 and 1 is 1.
This is 5. That's 5. This one.
Yeah.
Okay. So we've understood the bitwise, and then there is this bit which is doing a shift to the product. Okay, let's see. That's a left shift. So what does this? So these shifts are
Binary. A. Shift
shift A
in binary
in
representation.
binary representation.
B.
Oh, okay. Shifts A in binary representation. B. These bits to the left, shifting in zeros from the right. Okay.
Can we just do that in practical so that you can see?
Shift A in binary representation B. 32 bits. Okay, we can always. The good thing we have. Where was it?
So just put a very small number like 2 and 4.
So
1 and 2.
we are shifting. Oh, let's shift. Okay, let me use it.
Please use a
Let's
small
have
number.
5 and
Yes.
4.
Yeah.
5 and 4 is 0, 100. Let's see the result, yeah?
Remove the and.
Oh,
Wait.
it's a shift.
Yeah, also the and on the. Yeah.
So, let's see the result.
Yes.
Since you have not understood it. Wow.
80.
Oh,
Okay.
man. Which conclusion?
4 to power 5 is 256. No. Ati?
Shifts A, which is in binary representation.
B. Less than 32 bits to the left.
The left, shifting the zeros from the right. Oh, think about that.
Shifting in zeros from the right.
So 32 bits. You have the full. This one in full will be like how many zeros?
28 zeros.
From here, we'll add 28 zeros.
Yeah.
Our shift is like now the zeros.
Becomes 1.
Yes.
No. It will be it will be more than 80.
From the
Shifting in zeros
it shifts
from the right.
it shifts now from
The right. Right is here. Yeah. Yeah. Please do one shift.
So one shift to.
Hey, we are wrong. Yeah.
So you're expecting a what?
I don't know.
Something very.
Oh.
Hey,
I think that is easier to work with.
how is it even a 4?
Replace.
Okay. 1, 2, 3. Hey, man. Will I rewrite all this?
No, just rate the value 0001, 0001, 1, and 0010. 10. Yeah, so we're shifting zeros at a, no, right.
Oh.
Right. One, two.
So, and
1,
4.
2. See, if at 1, this is just a theory.
I want to say this one was shifted to here.
No, I'm saying 001, 0001. You shift the 1
Which one? This one.
Yes,
Uh-huh.
two positions.
2 position from where
No.
this times?
No, here. Just
So
on the
1.
one.
Oh, we shifted this here.
1, 2.
Why do we shift it 1, 2?
Because you're shifting it to, yeah, which is 4.
We're
Which is
shifting
100.
it 2 times.
Yeah. So can we try with another number?
So I'm assuming if I have 3,
3.
let me not go far.
So it's 11, 1, 0.
So
yeah,
you're
1.
saying
1. So
it
like
will be 1,
1, 2,
2,
3.
3.
It's supposed to be 8 because it's 1, 0, 0.
So it should be here.
8. No, not there. 1000.
Kwani,
That one. So it
you
will
say
go 1, 2, 3. So it will be 1000, which is 8. 8. If my theory is correct.
this is wrong.
We have a one again.
No, it's now that one has been shifted, so it's 0. So 1000. It's 1000.
Uh-huh.
It's 1000. Yeah.
This is one we choose the next card. Ah, okay. So if we have
Try another one again.
5.
5. Okay.
5 is okay. Let me return this to 1. And this is 0.
0. So 5.
And this is 5 is
1, 0, 1, 1, yeah.
So
But you're not
1 we
supposed
want
to
to
say
shift.
101.
So 5. So it's
So it
like
will
we'll
be-
do it 5 times.
Yeah. So we go 1,
1, 2, 3.
4, and then now 5.
So you'll have a 0, 1. A 1, 0. Oh, no, let me return it. 1, 2,
3,
3, 4,
4, and then
5. So we'll have a 1.
yeah. So
Which number is this? It's a big number.
We have a bit of
Oh,
so that
oh no.
so
This
that
is
will
just
be
converting binary to.
2,
Can you
2, 2,
do that?
2,
Can you do that? Right?
8, 16. So this is 0, 1, 2, 3, 4, 5. That will be 32.
So this is 32.
Yes. Yeah.
Wait,
2,
okay.
4, 5.
2 to 5, yeah.
Okay, so we have gotten that logic.
Yeah.
Is it the name of 5? 6, 4.
Yeah.
So what I'm
So
saying,
5 shifts 4.
the conclusion.
No, but
Oh, we have
At least
understood.
we understand how she.
Yeah. So I think now that we now know,
we can try to understand this.
so
Can we use now real value?
now let's use real values.
Which was, let me see the kata.
So
The first number was, allow me to use the simplest. My code. Where are you?
oh, let's use this part
Yeah.
to solve using the past test. Yeah.
Yeah. So the first number is 1 and 2. Just let's do that.
So for 2,
Yeah.
what you do?
Okay. Wait.
Oh,
Let me share my screen. Um,
you love to see.
yeah. So we are here. Let's. No. Oh my God. Yeah. We're here. So we will be doing A bitways XOR.
B.
Bitways. I'm looking for bitways. XOR.
This one.
This one. XOR. B. I think this was enclosed. Here's N. Comma. A bitways and. And we're shifting it one time. It only has JavaScript.
So, yeah, let's see how.
We have
So, if so, let's use now 1 and 2. Yeah,
Yeah.
just
Can we
write.
just do it?
Yeah, just write
So
the
1,
one is
0, 0, 0, 1. 2 is 0, 0, 10. 1, 0. Yeah. Yes. Like, no, we are not running it yet. We are not, we're just trying to do it manually first. Yeah. So we'll do A bitways X or B. So the first A bitways B, bitways X or B is, it was, we return 1 if either, but not both.
yeah.
So here, 1, 0 and 1, we get a 1. 1, again, we get a 1. And then 0 and 0, we get 0, and then 0 again. Yeah. So this is 3. Okay. Yeah. And then A, sorry, logical and not logical because and we get, sorry, everything will be 0. 0. And then these zeros, we are shifting it 1 time. Again 0. Because we are supposed to shift ones. So the answer is 3. But why do we need to, like, what is the use of this? Because it's 0, 0, 0. Or in this case. Yeah. Let's try another one. We'll catch you all. Let's say 3 and 4. 3 and 4. That is 1. Yeah. And this one is 1, like that. So bitwise XOR will be 1, 1, 1, 0, 0. Sorry, 0. Yeah, 0, 1, 1, 1. And bitwise AND will be, everything will be 0, 0, 0, right? And then you shift 1, which is again 0. And 1, 1, 1 is 7. So I don't know.
1 1 1 is
Yeah, which is 3 plus 7 is, no, 4 plus 3 is 7. 7. Yes. 1, 8.
100 is 4, 1 1 is 5,
Yes.
10 is 11.
Is 1, 7.
Let's try.
No, I think the 1-digit number will always be 0, 0. But let's try with 1 double digit, like this, like the second test, like 5 and 19. Okay, let's try. Let's try. 3 and 3 will be 11 and 11. It will be, yeah, sorry, 11. So it will be 0.
Remember the return value here,
Yeah,
the result of
yeah.
you add to the rest.
How have you known you add?
You look at that. You are returning the result of get sum, which is function.
Yeah, which is,
Then you pass the.
so you're adding it.
So you should be adding what is here. Second. So,
How are you adding it? I'm not getting, because we have a comma.
okay, let's do 1 and 2.
1, 2. So this is yeah. So uh, the XOR will be 1. Yeah, 1 again, and then 0 0. Sorry, 0 0. Right, and then the AND will be 0 0 0 0. Yeah.
And if you shift,
It's still 0. We shift 1. We shift 1.
meaning if you add, we still have.
But why are we adding it?
Okay. According to this,
Yes.
are you saying we have a variable get sign?
Yes.
So this means every time you call this
I
variable,
can't hear you.
every time you
Yeah. So guys, we are out of time, but I would have loved to see how this would turn out. But let me run this to see if we'll get the answer. If not, we'll continue next week. No, we didn't get. We did not get. No, we are using A and B. Let me see. X, Y. Oh, sorry. Here again. X, Y. Ah, yeah. I'm really hoping it runs. Expected 3 got 0. Expected 24 got 2. Okay. But we are close. Yeah. At least we have values back. Okay. We'll continue next time. We'll continue next time. Yeah. Join us next Wednesday to see how this will turn out. Bye.
you're already